in the triangles, we're going to get more proportions, more ratios. We're going to go through, well, 3 theorems today. The top one, the side splitter theorem, says that if a line is parallel to one side of a triangle and intersects the other 2 sides, then it's going to divide those sides proportionally. Divide, split. It's going to split the sides proportionately. So we have triangle QXY, and RS is parallel to XY. This little segment, RS, is splitting the left side and the right side then. Left side, right side. The green proportion on the left side, QR over RX, has to equal the ratio on the right side, QS over SY. So they're not going to be split in half necessarily, but the ratio of the top to the bottom needs to be the same as the top to the bottom. So if these lengths were 2 and 3, then the ratio would be 2 to 3. So if I make QS equal 4, what does SY have to be so that it's 2 to 3 when it's reduced? 6. So the ratio of the left side is the same as the right side. 2 over 3 would reduce 2 over 3, or 4 over 6 would reduce to 2 over 3. Side splitter theorem splits the sides proportionately. From this theorem, they have a corollary. It says if you have 3 parallel lines, 3 or more parallel lines that intersect 2 transversals, then the segments that are on the transversals are going to be proportional. So I have these 3 parallel lines, A and B, those are representing the lengths of those segments, same as C and D. The ratio of A to B has to be the same as C to D. So anytime you have parallel lines, you're going to have proportional lengths in between them. Not necessarily congruent lengths, but they're going to be proportional. So if the ratio of A to B is 3 to 5, and I make D be 20, what does C have to be so that this is 3 to 5 when it's reduced? It would have to be 12, because 12 over 20 reduced by 4 gives me 3 over 5. So the ratios along those transversals have to be the same. Cool. Example 1. Find the value of y. You got a triangle, and MN, bless you, is splitting the 2 sides, and it's parallel to the 3rd side. So since it's splitting these 2 sides, then those 2 sides have to be proportional. So y over 12 has to equal 6 over 10 then. You could, and you'd get the same answer, Sarah. Yep. 10y would equal 72, so then we should get y to equal 7.2. Side splitter theorem. It splits the sides of the triangles proportionately. Next example. This is the corollary. So instead of a triangle, you just have multiple parallel lines. It says the segments joining the sides of trapezoid RSTU are parallel to its bases. We have to find the value of x and the value of y. Veronica, you want to find x first or y? Okay. Give me a proportion for x. Good. 6 over x equals 5 over 12.5. The left side here needs to be proportional to the right side. 75 equals 5x, right? 75 divided by 5 tells us x is equal to what? 15, all right. Jack, how about a proportion for y? 5 is to 6 as y is to 9. So 45 would equal 6y, right? Divide by 6 and y equals 7.5. Okay, Jack went across this way. That's totally fine. Veronica's stayed on the left and the right. Jack went back and forth. You can do them either way. Okay, they're going to be proportional either way. Questions on those first two? Okay, do the next two on your own. Colleen, what'd you do for your proportion on 3A, the triangle one? Okay, cross multiply, right? So then 5x equals 2.5x plus 3.75, thanks. Subtract that over, so then you get 2.5x equals 3.75, right? Okay, what's 3.75 divided by 2.5? 1.5, good. So for 3A, you should get 1.5. All right, 3B. Kylie, what'd you set up for x? Good. X over 30 equals 15 over 26. That would be one proportion you could use. Cross multiply 26x equals 450, right? Divide by 26. Kylie, what'd you come up with? Exactly. Some stupid gross decimal. Okay, leave it as a fraction. 225 over 13. You won't have one of those on your book assignment today where it's a gross decimal. If they're gross decimals, leave it as a fraction. No, because your calculator is only giving you those many. It would go on. It would go on. Yeah. Well, I don't know. Well, I know it's not a very nice decimal. Okay, y. Shai, what'd you do for y? And then y over 26. So 15y equals what? 429 divided by 15. What'd you get here? Did it stop at that? It did? Okay, so then this one you can leave as 28.6 because it stopped there.
So it stops at 1,000?
Yes, if it stops after 3 decimals, then you can write those 3 out.
Yeah.
Okay. Dawson?
Yeah.
Oh, really? Nice. Okay, third theorem for the day here. The Triangle-Angle-Bisector theorem.
That just sounded a lot.
It is. We kind of did one like this when we were talking about isosceles triangles, but this theorem works with any triangle. And it says, if a ray bisects an angle of a triangle, so angle A is getting bisected, then that ray is going to divide the opposite side into 2 segments, CD and DB, such that they're proportional to the other 2 sides of the triangle, AC and AB. So your proportion here says that CD is to DB as CA is to AB. If the length of CD is 1 and the length of DB is 2, then my ratio is 1 to 2. If CA is 5, then what does AB have to be? So that ratio is 1 to 2, 10. Okay? So the ratio of the side that's getting split needs to be the same as the other 2 sides. So if we go to the example number 4. JC, what would you put for your proportion on number 4? X is to 30 as? Good. As 24 is to 40. You get 18 after you cross multiply and divide. What? I don't know. Okay, go ahead and try number 5. Don't get confused with these ones. They look similar to what we were doing Thursday and Friday, but it's not a right triangle, so don't do adjacent legs and altitudes and stuff. That's not what today's is. Okay, today's is the angle bisector theorem. I think so. Dylan, what'd you do here? And then 5 over 8. 28.8 when you multiply them? Divided by 5, what'd you get, Dylan? Did it stop there? All right, you guys agree? You should.
Yeah.
Okay, here's today's homework. Page 400, 1 through 25 odds, 31, 33, and 37.